Morning, afternoon, evening, or wherever you are. So today we're going to go through a lot of content. We will be going through a workshop. We have code examples. We'll be talking about feature stores. We'll be talking about MLOps. We will go through a variety of different subjects today. So I'm going to go ahead and share my screen. So the main goals, we have a set of goals that I want everyone to leave with from this webinar. One is I want to make sure that everyone leaves knowing what a feature store is, how it really looks to use, and the difference between the different types of features. And we'll go into what that means, but really I want to be able to explain how streaming versus batch versus on-demand all look and work. So the agenda today, we'll start with just a high-level MLOps breakdown. I want to talk about what the goal of MLOps is, what it means. We'll go a little more concrete into the parts of an ML platform, and then even more in depth into feature stores. That will give a good basis of MLOps, the problem space, etc. And we'll kick off into the workshop. The workshop will include building and training and deploying a model on SageMaker using Featureform, Spark, and Redis. I'm going to leave a little bit of time for an LLM AI preview. A lot of people mentioned in the question with the sign up that they were curious about it. So I thought I'd give just a taste of it. We'll do a actual workshop / webinar on it soon. And yeah, and then we'll leave time for Q&A at then. At any point in time, if you have any questions, feel free to throw them in chat. There's lots of kind of natural breakpoints throughout the conversation that I will use to answer them. Awesome. Well, without any further ado, that's me. There's now 3 pictures of me on your screen. And founder and CEO here at Featureform. I started Featureform based on something I built at my last company. We were doing recommender systems, personalization, predicting subscription, predicting churn for over 100 million monthly active users. Doing that, we built a lot of stuff in-house that nowadays you'd call an MLOps or MLOps. And one thing in particular, which became the core piece of that whole infrastructure, was what nowadays we call a feature store. So we've open sourced that. So Featureform is open source. And since then, we've released a company around it. Great. Let's talk about MLOps. So these are the core and common metrics that I think about when I think about an ML team. There's the velocity, the throughputs, and the risks. The velocity is how fast an individual data scientist or ML engineer can move. Common pain points here that I see, especially around data, are things like having to write pipelines multiple times, like one pipeline for training, one pipeline for inference, having to pass things over the wall to data engineering teams, having to kind of that set of problems I would call velocity. It's the ability for a single person to iterate quickly. Throughput is like collaboration. Often I find that data scientists are reinventing the wheel. Like you will reinvent the same feature over and over again at different teams or different orgs or for different models. Because there's no clear way to search and discover, to do collaboration, to do versioning, to do just management of features, throughput becomes a huge issue. And finally, there are risks. Some risks are model risks. These are things like data drift and the like. Some risks are regulatory risks. So a lot of machine learning, especially we're talking fraud detection, is going to touch very sensitive data. And so making sure that your governance rules are set up correctly and all that is properly handled is going to be crucial to making sure that everything remains clean and smooth. Now, that with everything I said, I wasn't necessarily focusing on, hey, like the problems to solve are being able to serve data really quickly, or being able to solve them all quickly, or being able to scale to a certain number of users. Those are core problems to solve. We call them the engine problems. You need the right ML engine to be able to handle your latency throughput requirements. However, we found that most people, most teams that we talk to and work with, they won't put, lots of the problems that they have are actually at the workflow layer. This is the layer of people. Like what's the process that a data scientist uses to get a feature in production, to share them, to reuse them, to use them in other models, to get it checked off by governance. That whole workflow is typically completely ad hoc, honestly. There isn't really much there, and a lot more time is spent on the engine piece. So throughout this presentation, we'll be talking about both, but Featureform is specifically designed not to necessarily be a faster or better Redis or Spark. That's why we use Redis and Spark, but rather to provide a standardized workflow to define, manage, and serve features. Great. Let's talk about the MLOps platform. These are the 4 modes that, as a data scientist or an ML engineer, you'll be in at any point in time. The first one is the data part. This is everything from analysis, just understanding what the data is, to feature engineering, to deployment. So I'll just call it data. Experimentation and training. This is where you're going to see hyperparameter tuning, experiment tracking, training, especially if you're doing like multi-node training. All of that kind of lives in experimentation. At the end of experimentation, you will end up with a trained model. Then you have to deploy it. So that goes to the next stage. How do I take a trained model and deploy it in production? There's a set of problems here that also exist, such as like canary testing, A/B testing models, etc. But deployment's another core thing. And finally, there's monitoring and evaluation. So once a model's in production, you want to monitor it. You want to understand how it's doing. You want to evaluate its performance and use that information to go back to these other modes. It's not necessarily linear, like I'm framing it. In practice, we're kind of jumping around back and forth between them to continue to iterate on their model. Unlike software, data science and ML is a very iterative process, which makes it unique. Feature Source specifically focus on this first mode, the data part. So Feature Source aims to solve problems around the data part of machine learning. So it's a lot of scope. We have a long write-up about how we break down the layers of an ML platform. You can see at the bottom, I have those 4 modes from data, experimentation, deployment, monitoring. And on the left, I have the layers. These are more abstraction layers. At the bottom level, it's hardware. And then it goes up to compute frameworks like Kubernetes, services, which are things like Spark and Redis, workflows. These are the orchestrators where Featureform lives. And finally, the platform layer, which is kind of the broad abstraction over all of this that the data scientists interact with. So feature stores, and specifically Featureform, we call ourselves a virtual feature store, sits in the workflow layer. So it adds a workflow on top of Spark, Redis, and Pandas, and orchestrates them and makes them work together in a way that makes sense for machine learning. So let's dive deeper into that. First, let's talk about how we would build a feature today. Without any feature store, without Featureform, just how do data scientists build features? Well, typically, we're going to be working in a notebook. We'll use that notebook to define a set of transformations on top of our data sources. That could be on Snowflake, it could be on Spark, it could be in S3 data, it could be on Kafka, it could be in a lot of different places. So we're using the notebook. I'm using it to experiment, come up with features, come up with ideas, analyze the data, and eventually to productionize it. Productionizing it may be a set of bash scripts as well as things that can be done in the notebook, depends on the platform. And this could be things like running a Spark submit. It could be things, a variety of different things to get those features in production. So we need to kind of experiment, analyze, and deploy the features to get in production. And similarly, once it's deployed, we want to monitor them, evaluate them, etc. So these are the steps to get a feature in production, to build a feature. In practice, I built this meme kind of tongue in cheek because these are all things I've seen, and honestly, a few of them I've done myself. Even though it is possible to get features in production, like if you have models in production, you've gone through the process I just described. The problem that we kind of run into and see, part of why Featureform was built was to solve the problem of that whole process being very ad hoc, being very fragmented, where you'll kind of be throwing things over the wall between different teams or different people, and completely, as it shows at the bottom, completely undocumented. I have a few more memes for you to wake you up this morning. I have a lot of notebooks with some DF finals in them. And finally, just to top it off with one last little meme, this probably looks kind of familiar. So that's where Featureform comes in. That's the layer that we live on. Data scientists are still defining their logic in SQL and Python and PySpark with a notebook, perhaps. They're defining things in Featureform via our Python framework. We store that metadata and then we will orchestrate the engine. The engine can be Spark, it can be Redis, it can be AWS, it can be on Azure, it can be on-prem. It doesn't really matter. The point is that there's kind of this middle layer, this framework for specifically built for feature engineering and deployment. So I have a little deep dive here that I put together. So I'll switch out of this slide so I can zoom in and talk through it. This will really break down the components that make up a feature store. So as I jump back into here, right, so I'll share. Cool. So this looks similar to what I just showed you. So there's kind of, data scientists on left and right, there's models. Let's start with the two pieces of, or the infrastructure. So this is what you all likely have today if you were deploying features. The infrastructure is, we break it down into two categories: offline stores and inference stores. Inference stores in practice are kind of like a cache. So when you're serving features in production, so when you have a production model, it needs to have features served to it. Now, in practice, most of the time, these features are pre-processed and then cached in something like Redis, Cassandra, Dynamo. It could be via streaming, it could be in batch. There's also the idea of on-demand features, which I'll get into, where it's actually just done at request time. On the left is the offline store. So the offline store can be something just like Snowflake that can do all of it. It can be a mix of things like Spark and S3. You could be using pandas, you might be using Postgres. Point is that this is the place where you would build your features, you would define how, the transformations to build them, you would build your training sets and store your training sets all in the offline store. So offline store is kind of where most of the heavy lifting is done, and the inference stores where the caching is done. Now, like I mentioned in that slide, currently it's typically on the data scientists, or perhaps the data scientist in another team, to actually take all that stuff and get it into production. So the goal of Featureform is to provide an application layer on top of the infrastructure. So in Featureform, you will define the declarative API to define your sources, your transformations, your features, your labels, your providers, your training sets. It will then, you see this kind of little guy down here, it will actually take these definitions and orchestrate your infrastructure to achieve that desired state. The name Featureform actually comes from Terraform, so that practice of like defining things and having something orchestrated is very much something we kind of borrowed from Terraform's ideology. It provides other components that are kind of critical to the feature pipeline, the feature engineering workflow that the infrastructure may be unaware of. This is things like search and discovery of features. So it's actual searching, versioning, sharing, being able to see lineage and the DAG. Like, what is this training set? What features make it up? How are those features defined? Governance and access control, monitoring both for uptime and for data drift, which is again a uniquely machine learning concept where your data in production might actually have slightly different distributions than the data you use to train. And finally, serving. For serving, you're gonna need to serve for both training and inference. You'd like to have one place you can serve for both, so you don't have to maintain two different pipelines. You want to be fast, typically, or at least as fast as the infrastructure you're using. And for serving, we have the idea of an on-demand function, which I'll get into. So as a data scientist, kind of zooming out, you'll be using the Python API, which I'll show momentarily, to define these definitions. You can use the dashboard as well. Not so much to define things, but to look at things, to search things, to discover things, setting up governance, the monitoring, etc. All that can be done via the dashboard. Models, on the other hand, have two APIs that they will be using. The inference API, which will serve them for when they're deployed in production, and the training API, which will serve them for training. So all this comes together and builds your stack. So this is the feature engineering stack. If you have any questions, also I know I'm going through this sort of quickly. If you have questions that come up, please feel free to throw them in chat. Great. Let's talk fraud detection. So what is fraud detection? What is fraud detection? The concept's kind of simple. You have typically a stream of data, some sort of time series. And in this case, we're going to be using transaction data of like pretty much like credit card transactions. And the goal of a fraud detection model is to identify which transactions are fraudulent. In practice, there's many ways to make your model perform better. I'm going to break it down into very much simplify it into two categories. There's the feature engineering category and then the model category. The model category is things like choosing which algorithm to use, hyperparameter tuning, playing around with the model itself, which is sometimes it's like the black box model. On the other side, there's the feature engineering. This is taking the data that you have and working on it to pull more signal that you provide to the model. In things like computer vision, they're typically very model heavy and not very pre-processing and feature heavy. On the other hand, things like fraud detection are extremely feature engineering heavy. Most of the quality you'll get and the increases in performance you'll get are typically going to come from working with the features. And like I said, it's often streaming data, so that comes with its own set of problems, which I'll talk about. Cool. So I'm going to go through this. For this workshop, I'm mostly just going to be running this through myself. We're planning to have a longer form workshop where we can actually have a smaller group of people. We'll have more people from the Featureform team online, and we can actually walk you through doing this as well and to help you live debug, etc. So in this case, I'm just going to walk through how to build things and then deploy it. I have it deployed already just to save time, and then walk through that. So yeah, first step, we have to deploy Featureform. If there's any other infrastructure that you have, like Spark and Redis, that you don't have deployed, you'd probably want to deploy that as well here. So you kind of want to set up the full infrastructure stack to use. There are 4 ways to deploy Featureform. One is with a Terraform script. With this Terraform script, like the one I'm going to use that, it's not just going to deploy Featureform. It will deploy a Kubernetes cluster. It will set up your VPCs. It will do everything end to end. We have them for, I have an AWS one, which I'll use today. You can use Helm. Helm is a way, for those unfamiliar, Helm is a way to install applications on a Kubernetes cluster, an existing Kubernetes cluster. So the Terraform script uses Helm. We have a single standalone Docker container that you can deploy. The Docker container is great for testing, for working with Featureform. It isn't necessarily meant or built for production because it doesn't scale horizontally, so it's kind of stuck to one node. And then finally, the easiest way to use Featureform, like if I wanted, and I was a data scientist and I just wanted to like go and play around with it, you can actually just pip install Featureform and start using it locally. So I mentioned that there's an offline store and an online store. In this case, both the offline and online store would just be your laptop. So you're not really deploying in production in that case, but you can still define features, use the dashboard, build training sets, train models, everything locally. So just to give you kind of a quick touch of what we've deployed. If I go, let's find my terminal so I can share it with y'all. And again, I know I'm going through a lot, so if you have any questions, please feel free to ask in chat. Okay, so I have this terminal. So I'm in our Terraform, where we have Terraform. I don't know if this is sharing correctly. Oh, there it is. So yeah, I have this Terraform, all these Terraform files. I have some state. If I Terraform apply, it creates a whole stack pretty much from scratch that has all the VPCs, everything's all set up. It's 50 things. So that's because we actually built the whole network stack as well. So that's how Terraform works. There's also Helm. So if I Helm list, Helm is a way to deploy in Kubernetes. So I could, use this to see if I have Helm installed. I could even like look directly at Kubernetes. And if I get pods, I can see all my pods and like my services and everything. So there's like a metadata service, there's a dashboard, there's a coordinator, which is like the orchestrator, there's the actual feature serving, there's Prometheus for monitoring, there's metadata, and then I deploy a Postgres and Redis and a few other things just for this quick start. Yeah, and like I said, you can always just use Featureform just standalone, which I'll show a quick example of, but that's also kind of available to you. Cool. So I'll switch to back to my Chrome so I can show you a little more about the deployment and then jump into the notebook. So yeah, the other thing that I've deployed, so like I said, you can see in Kubernetes, you can see all the pods that were deployed. The other thing I deployed is a SageMaker instance. So the way SageMaker works, it has ways to kick off training. It has ways to deploy for production for models. It kind of works off of a notebook server. So you first deploy a notebook server, and then you actually deploy your models out of that notebook. It's kind of the approach they've taken. So I'll kind of walk through that. So our actual fraud detection webinar is actually in a it's in a Jupyter notebook, but specifically in a Jupyter notebook of SageMaker. Like you can see, I'm using SageMaker and end of this to actually train my model. So I'm actually going to walk through this first, and then I'm going to come back and talk about the different types of features. So the goal of this one isn't necessarily to show you all the different types of feature engineering. I just want to walk you through the simplest possible example of how to use Featureform end to end. It's batch. This one's going to be batch. It's going to use Spark. It's going to use Redis. So I'll pivot to Featureform. I will connect to my client. There'll be a host. I can collect that host. In this situation, I'm starting with a clean slate. So I'm registering my infrastructure here for the first time. In most cases, this infrastructure will either already be defined, or it can be defined even like the dashboard. In those situations, you can actually just get these things, so you don't have to register them each time. You can just say, hey, get me this Redis, or get me this S3 or Databricks. So yeah, I'm registering Redis. That's going to be my inference store. S3 and Databricks, which the Spark part of Databricks, kind of come together to build my offline store. Now I get into actually defining my actual definitions. So going back here real quick, what I've done so far is I've registered my infrastructure providers. My offline store is Spark and S3. My online store is Redis. Now I get to the Featureform layer, and I'm going to define all these feature definitions: the sources, the transformations, the features, the labels, and the training sets. I've already defined the providers. Oops. This one. So first thing I'm going to do, I can set, as I'm experimenting, everything in Featureform has a version, but I can use ff.setRun to kind of set the generic the version of this experiment, so it can kind of group all these things together. Then I'm going to register my first source. It's called transactions, and the version will be experiment because that's what setRun is. And then this is the path to it. I can now define my transformations. And again, this is going to be a batch transformation. Featureform supports both SQL and data frames for pre-processed transformations. So this is the SQL one, very simple. It just takes that transactions thing I registered, that file, and I just take the average transaction amount from it. Once this is defined, I can call client.dataframe, which would actually allow me to get this transformation, or the output of this is the data frame that I can play with locally. I can even set a number of rows if I just want to sample it, if I just want to. So part of Featureform's goal and design is to make it as simple as possible to kind of fit into your normal workflow. We're not trying to like build a whole new thing for you to figure out. We're trying to keep it as simple as possible. We're providing just enough structure that we can automate away everything else, like dealing with the infrastructure, getting things in production, monitoring, versioning, etc. I can also define a data frame transformation. Notice that my input is actually the SQL transformation. So I'm building a DAG here. So I'm taking that first file, I'm transforming it, and then I'm mean shifting it with PySpark in this case. So I take the mean, I aggregate it, and then I subtract it from every single row. Great. So now I've built these transformations. Now, when you think like a table or a transformation, what you end up with is just like a table. It's unclear to both Featureform and a data scientist which columns of those tables are features, which columns make up the primary key, or so like typically the feature is going to be a value and then there'll be a set of entities. For example, it can be a value attached to a customer ID. It could be a value attached to an item ID. And typically there's also a timestamp, which you're going to want to use to do point in time correctness. Point in time correctness is this concept of getting a feature's value at a specific point in time for training. So how we do that in Featureform is we create an entity. In this case, the entity is called user. We register and associate, in this case, just a single feature and a single label with the user. So this feature is that transformation with these two columns. The type is a type, inference store. This is where the inference store for this feature. If we're planning to use this feature in production, we can set an inference store and Featureform will automatically materialize this feature to the inference store. The label is a label in the machine learning sense of it's kind of what you're trying to predict to use for training. And so we have a label column, which is fraud, which we'll use to predict. We'll register this training set. We'll set the label. We'll set the list of features, and then we will apply it. It will create all those things for us. And once they're created, I didn't open up the dashboard, but I'll show like a different dashboard. You can look at all the things that were created. You can look at how they're defined. You can look at features that are associated with them. You can have tags. You can look at different versions. All of that is kind of available to you in the dashboard, as well as monitoring. So you could also, like, if I go here, I can look at different throughput, latency errors, and other things for all my features. Once that I have a train set and it's created, I can start using it. There's two ways to use it. One is as a data frame, which is what I'm doing here. You can just pull the whole thing as a data frame, especially if it's a relatively small data set. There's also the streaming version where you can actually batch it. So you can like kind of loop through in batches and train that way. Yeah, both ways are available to you. So I'm going to get this thing as a data frame. I'll do in this case, I'll do a train test split in the data frame way to get a train and a test thing. I'll upload them to SageMaker so that I can train. I will set up some hyperparameters, which again, I could play around with if I wanted to. I'm going to use SageMaker's pre-included XGBoost algorithm, which is just a form of a random forest or just a boosting algorithm. And yeah, training is very simple. You just set the image URI, which is like the algorithm. You set the hyperparameters. You can set how many instances you want to train on and the volume size. So everything from here down has been kind of SageMaker specific training. And when I set the training input and the validation input, I will use the stuff I got from Featureform. And I can finally use that to train a model. So this will train, it will kind of get some sort of loss. From this point, I can actually deploy from here. And when I'm deploying, I can now use features. Again, I can serve features from Featureform to feed that model in production. Any questions so far? So there are three types of features. Notice that the transformations of the features I showed you right now was using S3 into Databricks. So that would build the feature at that point, and I could use it to build the training set. Now, let's say there are new files added into S3 every hour or every day or whatever. Or let's say that I have a stream of data. Or finally, let's say that there are features I have where the features like input data is presented at request time. For example, I might have a feature which is the square root of the transaction amount of the current transaction. So when it's the current transaction, it's going to be a little different. So the way the way you can think of this is that there's kind of pre-processed features and post-processed features. So when a request comes in on that top right, it goes to it wouldn't go to the model directly, but it would kind of come into something. And if the features that the model needs can be or have been pre-computed, they will either be pre-computed in batch, which would be on some sort of cadence. It could just be once, or it will be streaming, which is near real time because there is typically still a delay. And for example, this specific request would not make it through the stream in time. And so there are streaming features and batch features. Those are kept up to date in the inference store by Featureform. And then the final type of feature is an on-demand feature. An on-demand feature is essentially a stored Python function. It's like a stored procedure that is applied to data in the actual request to build any last features. On-demand functions also have access to the inference store. So it's very common, for example, to take a value from the request and subtract it by the mean, the average value in the inference store. So you can kind of mix and match and merge these things. I'll show a few examples in code. Oops. Okay, that's fine. I'll just show you all the code. So let's talk about an on-demand feature first. Like I said, an on-demand feature is kind of like a post-process feature. A lot of feature stores are really focused on the pre-processing of features. So an on-demand feature is a feature that has to be processed at request time. So it won't be stored in Redis. This is an example where I take the price, which is a parameter, and I divide it by a scaling factor, which happens to be in the feature store. Now, on-demand features don't have to use features in the feature store, in the inference store rather, but they can. And so you can kind of do it in many different ways. Once this thing is defined, when I do a typical like a features call, like the way I would get my features, I would set my parameters and I would set my entities if I need to, and I can work off of that, and it will print the value, which I would get. The other two kind I want to talk about, one is streaming feature. So when you define a feature, you can also define it as a stream. Now, handling a stream of data is fine. One thing to think about when you're dealing with streaming data is that when you're training with a stream, you're going to need to have historical feature values. So in this case, every event that comes in is processed by Featureform, cached in the inference store, and there's a historical log of features that would be kept in the offline store. In this example, it would be Snowflake. This is used so that when you're training, if I have a label, so it's like, hey, I have a transaction from 3 months ago, I need to know what the feature values of that training row were 3 months ago. And so that's how this is handled in Featureform. You can also use this to backfill. So you can backfill a log with features or historical features that you have when you're building a new one. I should add that streaming is not in open source. It's an enterprise only thing, but pretty much, I believe pretty much everything else I've talked about other than governance and access control is going to be in open source. And the final kind of feature I talked about is the batch feature. So I showed an example of this, but one thing I didn't show is the idea of a schedule and an incremental update. So you can set up your features, your transformations to be incremental, so that if it's incremental, you can kind of update or work on a smaller piece of data every time it's scheduled. And the schedule just means it will run, in this case, it will run every morning at 8 a.m. If you combine these things together, the batch, scheduled batch, streaming, and on demand, you can kind of get the right set of features that you need to train your model. And so for fraud detection, for example, it's super common to have all three and use all three. There's a lot of streaming features, which will just be things like the last 5 things the user bought, the last thing the user bought. On-demand features are just things that happen and transformations that happen on that specific transaction before it goes into the model. And finally, there's the batch ones, which typically will happen when you have aggregations or like large windows, like 30-day windows that you need. When you define all this in Featureform, all the complexity of those 3 things kind of disappears. They all get unified in one place, in one repository that, like I mentioned, you can search and discover from, you can reuse from, you have for both training and for inference, for production. You get governance and access control. All of that is given because all of these things are just one concept to us. They're all just different types of features. One last thing I'll show here, just because it sometimes will come up, is dealing with high cardinality features. Sometimes you'll have a feature where there are just billions of values, and storing that in something like even like Redis doesn't really make sense. And so one thing that's also cool about Featureform's approach, the fact that you can plug in the providers, means that you can mix and match providers. So you can have a feature in Redis and a feature in Cassandra. If you feel like Cassandra is the right infrastructure for this feature and then Redis is the right one for the other one, you can have both of those be defined together. And it's kind of abstracted away from you because Featureform will just coordinate and orchestrate all that for you. And TTL is another way to kind of solve that same problem. Cool. So we just walked through, it's very simple, but we just walked through how to register our providers, register our sources and transformations in Featureform, register our features, labels, and training sets, use it to train a model in SageMaker. We looked at how the dashboard can be used to search these things, reuse things, version things, and tag things. We looked at how you can use on-demand features as well as incremental and scheduled batch features, as well as streaming features all together to achieve kind of your desired set of features. And all that comes together to give you that full standardized feature workflow experience. Any questions? I know there's a lot of information and I went through it quite quickly, but I wanted to make sure I left at least a little bit of time for questions. I know it's early. Okay. So if you have any questions, definitely throw them in chat. I'll take a moment and just, I know I saw when a lot of people signed up that there were some questions about our LLM functionality, just because we had released that recently and we'd released some posts about it. I thought it was kind of fun and relevant here because actually our LLM examples use both on-demand features and batch features together. So I thought I could give like a quick taste of it. Again, we've done longer workshops and webinars on LLMs, and we will do more in the future. For the thing I just showed you on fraud detection, also just a note, I do plan to do a longer form one. This one was like about an hour, and even then I like kind of rushed and cut through things, and it still kind of gets to an hour. So we plan to do a longer form one where we will actually sit with you. You will deploy it. We'll get you credits on AWS or wherever else. We'll help you debug, and we'll actually build and deploy a model together. That will likely be close to like 2 or 3 hours. And then we will share the video later, for this video later, as well as the slides. This is recorded, right, Shep? So yeah, actually the video also goes on LinkedIn and automatically. So if you go to our and Twitter, so if you go to our LinkedIn or Twitter page, it's actually being streamed there right now. I should check the questions on there. I'm sorry if someone's asking a question.
I've been checking, Simba. And yeah, I'll send out a follow-up email to everyone that includes the YouTube video as well.
Cool. And then yeah, LLMs. Again, I'll give a longer one. If you've heard the concept of RAG, which is the idea of mixing, contextualizing a prompt with features, something that Featureform orchestrates. So I'm not going to explain all this in this one. We don't have time, but just know that the typical process of actually getting an LLM into production is typically a very data-heavy problem to solve. And I have this other notebook I put up, which is our chatbot one. And I want to show you all a few things on this. One is like, this is local mode. So this is actually working on a local, just on a local notebook or laptop. I still define things very similar, like registering a directory. I can call client.dataframe, like I mentioned, to get and see data and interact with it as a data frame. I can still define transformations. It looks very similar. I can define data frame ones or SQL. I can, going down a bit, even for complex transformations where you're using a model in a transformation, like I am here to build an embedding, all of it fits very nicely into how Featureform does things. So here I'm just taking a sentence transformer and encoding text. This is actually a chatbot app with our podcast, which you should check out. And then we register our features. We have a normal feature and embedding feature. Again, we have that vector DB in this case, which is like an inference store, but a specialized one for nearest neighbor lookup. And then finally, I'm doing on-demand features here. So in this case, in my on-demand feature, I'm actually using a sentence transformer model again to take content, vectorize it, and then get the nearest neighbors. All of this is using Featureform. So even though Featureform underneath the hood in this example is using Hugging Face and Pinecone, the orchestration, the versioning, the storage of all this is done in Featureform. So Featureform is, again, that framework that sits above it all to allow you to use data and machine learning and LMs as well. So that's just a taste, just because we're going to probably send one out for LLMs and a few other things. So we have a lot of things we can talk about. If you have any questions, any last questions, obviously feel free to ask. If not, and you have a question that comes up later, maybe as you're watching the video, maybe as you're just like processing what we talked about today, feel free to join our Featureform community. You can, Shab will include it in Slack, but if you go to our GitHub repo, so if you Google GitHub Featureform, you should be able to see a place where you can join the community. I'm very available to answer questions, as well as our team. You can always email me at simba@featureform as well. And yeah, I hope this was useful. I know it was a lot of information in a small amount of time. We kind of are playing around with this new format. Let us know what you think. If you loved it, let us know. If you didn't like it, that's fine too. Please let us know so we can do better next time. Give one last minute for data, or for data, for questions. Otherwise, I'll give you all back a few more minutes of your morning. Awesome. Great, thank you. Yeah, we got people dropping off now, so I think we're good to go. Thanks again, everyone, for the time, and hope this was useful.